Hello, in this video I'm going to give some background to Joseph Louis Gay-Lussac, who we mentioned in the ideal gas laws, because one of the ideal gas laws, the relationship between pressure and temperature, how they're proportional to each other, is named after Gay-Lussac. So it's well worth knowing a bit more about him. So he was a French chemist and physicist, and you can see from this picture that he was relatively well-to-do. So he was born into a wealthy family who owned land in central France. And he was born in 1778, which is interesting in itself because that is around about 150 years after Robert Boyle was born. So you've got Boyle's law of the inverse relationship between pressure and volume, which was developed way earlier than the other two laws, the relationships, will bringing temperature in. So saying that volume and pressure are both proportional to the temperature. So, I mean, this just underlines the difficulty that scientists had at the time of bringing temperature in and understanding what heat and temperature and such like actually meant and how to describe it. So that came much later, and we can see this from the date range that Gay-Lussac was operating. So, yeah, he was born in 1778. And he was educated at a Catholic abbey, and then he moved to Paris to complete his education. And then he became a professor of chemistry and then of physics at the Sorbonne, which is the great university in Paris, one of the great seats of learning in the world. So, yeah, he was a real big hitter in the university scene. And he made so many discoveries and had such an impact both in chemistry and in physics that his name was one of the 72 names that was inscribed on the Eiffel Tower when it was built towards the end of the 19th century. So what else did he discover then? I mean, we've got, in 1802 was when he published the proportionality between volume and temperature for a fixed pressure, which is now largely credited as being Charles's law. So Gay-Lussac had developed this, but he was aware of the work that Charles had done in order to give him the credit for work that this discovery had already made. But then the pressure being proportional, too many P's, pressure being proportional to temperature was then named after Gay-Lussac. Now in 1804, I suppose he also followed to some extent Charles's footsteps here, because he flew up to a height of an altitude of 7 kilometers in a solo piloted hydrogen balloon. So it was just him in a hydrogen balloon going up to 7-kilometer altitude in order to investigate the Earth's atmosphere. And it led to the discovery that the composition of the atmosphere doesn't change very much with altitude. And it also makes you wonder, as a budding scientist, as I assume you are, otherwise you wouldn't be watching these videos, well, to what extent would you be willing to put yourself on the line in order to make these discoveries? I mean, this guy's gone up over 200 years ago in a balloon filled with hydrogen in order to take these measurements. So that's some daring that, well, deserves some credit, I think. In 1805, he was working with Alexander von Humboldt on the composition of water. And they jointly discovered then that water is composed of 2 parts hydrogen and 1 part oxygen. So another one of his great discoveries in chemistry that he continued with, he co-discovered boron in 1808, along with his compatriot Thenard, and Humphrey Davy was also, I think he did a similar thing, maybe even independently. And then he discovered the law of combining volumes in chemical reactions. So you can reduce the reaction of gases in chemistry to integer ratios. We're always going to be getting a certain number of atoms moving one way or the other, and we're building these things up in atoms. You must be able to describe the reactions in integer terms. So that was the law that he came up with then, of the law of combining volumes. And then Avogadro, he then extended that into saying, well, here we've got ratios of molecules. It's not just these volumes that we're talking about, because as Avogadro showed, that the volumes are then proportional to the number of molecules. If you've got the same volume of two gases at the same pressure, then you've got the same number of molecules in each one. So if you're then doing a ratio of volumes, you're doing a ratio of molecules. So that's all led to one thing and another. And of course, Avogadro, of course, was a contemporary here of Gay-Lussac. He was born more or less at the same time and died at about the same time as well. So they were very much contemporaries. In 1811, Gay-Lussac, he recognised iodine as a new element. And then he's also invented a lot of things as well. So in chemistry, I mean, he coined the term pipette. He developed an improved model of the burette. So, the burettes, they're the things that you often use in things like titration. They're the tubes you get with the markers on, and a sort of stopcock thing at the bottom. And then you can let little bits of water to high, or any liquid, to high accuracy just by titrating these things into your experiments in chemistry. So he developed a lot of things. He was a multi-talented guy, making breakthroughs in chemistry, physics, inventing, and it's no wonder that he was honoured on the Eiffel Tower in that way. So a often overlooked name in science, really, considering his impact.